Hello. How are we doing? Good. All right. Today we're going to talk about how we can move from prompt spaghetti to production code using two of my favorite tools, DSPy and Dagster. My name is Pedram Naveed. I run developer marketing at Dagster Labs. And yeah, I guess we'll get started. So if you've written LLM code, if you've built LLM applications, I'm sure you've followed some type of workflow that kind of looks like this. You start off with a notebook on some idea that you're prototyping and you're not even sure if it's going to work. And then you have the unfortunate problem where it does work and now you're expected to somehow make that thing run in production. And so you quickly convert it to Python, or you ask Claude to convert it to Python, and you put it into production, and it works fine for the first few hours. And then you get paged at 3 in the morning and nothing's working and you don't know why. Now, that probably sounds really familiar to you if you've built LLM applications. A lot of this is because you're bargaining with the devil in many ways. You're begging this thing that you hope will listen to you, will do as you ask, because you're used to programs doing things that you tell them, as long as you tell them correctly. But with LLMs, it's a little bit different. You got to beg, you got to sell your soul a little bit, you got to really tell your life depends on this thing, and then you'll kill kittens if it doesn't return JSON, and sometimes it'll listen to you. And that's probably how we typically build LLM applications today. And the problem is, even if you build the perfect prompt, what happens when the model changes in 6 months and it's a whole new model and the prompt doesn't work anymore and it all falls apart again? You got to start from scratch. And in many ways, what I think is happening with LLMs is kind of where we went with data engineering for a long time. If you've been around data engineering long enough, you probably remember brittle pipelines that break constantly, random cron scripts all put together in some weird way. But for the most part, we kind of solve these problems. It doesn't mean you solve them, but we know how to solve them. Generally, assuming you have the time and resources, you can build a pretty good modern data pipeline with great tooling today. You get declarative automation, you can get a lineage of your data sets, you get really good retries, you get great testing and validation, and you get to build production-ready pipelines by default. And we have it almost too easy now, where building pipelines is kind of boring in many ways. LLMs are in the opposite world, where it's never boring because it's a new experience every 5 minutes. It feels like everything falls apart the moment you try to build it. It's a random hodgepodge of manual prompt engineering. There's often no version control of these things. You pray and hope things work, and often they don't. There's very little automated testing. You're not even sure how to test things yet. So the thing is, maybe it doesn't have to suck though, right? Maybe this is just the beginning phases of LLM applications, and there are possibilities here of how we can make things a little bit better. It's possible to maybe have code that is self-optimizing, right? You start with a prompt, and given some inputs and some outputs that you expect, maybe the prompt could optimize itself. It's possible to come in and build things that are maybe production ready, and maybe it's possible to have observability, full lineage of your LLM pipelines. And my proposal to you is that there's a tool out there that's very similar to a tool that we work on, a Dagster, that kind of merges the same sort of philosophy together. If you don't know about Dagster, Dagster is a data orchestration tool. If you are familiar with Airflow, it's like Airflow but better. It's kind of my pitch to all of you. It's built from the ground up with really good, solid software engineering principles. You define your data sets rather than your tasks. And so what you get are a nice bunch of out-of-the-box primitives you can work on. You get a really nice way to build data platforms. And it's production ready, used by very large companies, and it's just great, powerful tool out of the box. If you're not familiar with DSPy, it's fairly new, I would say. But when you squint, it kind of has the same sort of principles as Dagster does. And I think the reason why I'm really excited about Dagster and DSPy is because together they form this single philosophy on building modular applications that are really through programming rather than to ad hoc code. And it kind of eliminates that manual prompt engineering we're probably all very used to. And so Dagster, I talked a little bit about this. The kind of principles behind it is it's asset-centric. And what this means is if you're used to Airflow, you've often said run task A and then run task B. And what happens in that box, don't really know what's going on. Dagster flips that around and says, don't tell me about the task. Tell me about the things you actually care about. Your files in S3, your models, your tables, all that. And what happens is when you start to model your data differently, you can become more declarative about your intentions rather than about a black box of things. And so you could say things like, this dashboard at the very end, that's the thing I care about. Find the fastest path to making sure that dashboard is refreshed every 24 hours. That's a very declarative way of building pipelines, rather than being very much task-oriented, where you have a schedule, and you got to make sure you figure out the backwards math in terms of how long it would take to get these things to run. The other nice thing is you get a lot of observability in this way, right? If you define your data sets as assets rather than as tasks, you get a data catalog for free. You've essentially built a data catalog through your orchestrator, and you get to have these very fine-grained testable units. You can test individual assets and assert certain things about them. Compared to assets and tasks, they're not that different. My Python broke, so don't look too much at my code. There's supposed to be some line breaks in here, but essentially they're decorators. A task is defined as a thing you would do, and an asset is defined a thing you care about. And so on the left, you have several supposedly functions in here. One is called extract, one is load from S3. On the right, we have assets. You just define your customer transcripts data set. And with Dagster Components, you can actually define configuration as code. And so another little nice primitive we've built is this thing called components, which lets you use things like YAML to define the business logic, and then you have your orchestration logic in your Python. And so, again, if you had better line breaks in this code, what you would see is you can actually define in YAML the type of transformation you want to do, the name, the query, and that gets defined separately from the actual orchestration logic and helps you build really reusable components that are very modular. DSPy has a very similar sort of approach. They propose that you never write prompts manually again. Instead, what you focus on are signatures, and I'll kind of show you what they look like. But essentially, a signature is like the declaration of intent. Here's the thing I want an LLM to do. Here's my input. Here's my output. Now you go figure out the best way to make that happen. And so the magic of declarative pipelines with DSPy is, on the left is a prompt you've probably all built. You can imagine, a Python function, a big string, and then you say, please return the contents of this string for me. On the right, what you have is a DSPy signature, which is really an input field, one or more input fields really, and then output fields, and that's it. Then you just call that class, and DSPy will retrieve those inputs, format that as an output, and let you access the output from that class. And what really I don't believe these numbers, but I actually did run it. These are my numbers, so I know they're real. I ran a puzzle, it's like a New York Times connections puzzle, just to see how DSPy works. And if you're not familiar with New York Times connections, essentially you got, I think, a bunch of words, and you got to find groups of 4, and you have 6 chances to find them. And if you do all 4 groups correctly, you win within the time set, right? It's a fun puzzle because it's very hard for LLMs to do this really well natively. It's not a solved problem. It's like you got to have some creative thinking. But it's tractable in that there is an answer, a question and an answer, and you can test the results of these things. And so I ran a simple just base model on New York Times connections. I think I ran 50 or 100 of these. And this was on, I think, Grok 3. And before any optimization, I got a 32% success rate. The only thing I did is I asked DSPy to optimize my pipeline. And after optimization, it went from 32 to 53% correct. Same model, no manual prompt tuning, no feature engineering at all. All I did was ask DSPy to optimize this model based on this evaluation criteria. And so you can get a 21% improvement just like that. And this was on the easiest mode, not a lot of work, cost $9, I think, total in optimization as well. So what I think is really interesting is you can start to imagine a world where you merge these two tools together, right? On the orchestration side, Dagster can handle a lot of your dependencies, your schedules, your production concerns. And then on the AI layer, you got a tool like DSPy, which handles the optimization of prompts, handles LLMs, and can be the interactive layer that helps you bridge the gap between AI applications and data engineering. And then what's nice is you can get observability through this entire thing. Here's a sample of how I would create a DSPy component in Dagster. Again, imagine there's line breaks here. I don't know what happened. But you basically can define a Python function that creates DSPy modules. It can have evals. It can have a baseline model, an optimized model, and some other things that you would want. You build that in Python, and then your YAML just defines the logic of what you want to do. So for example, here, I have a data set. I tell it, train test split is 25%. I say how many threads I want to run and what mode I want it to run. So you can see it's very declarative about the type of model I want to run, but the logic is contained elsewhere. And what that code gets you is something like this in Dagster. And so what you can see is it pulls the data, it creates a baseline model, it performs an eval on the baseline to get the performance, and then it creates an optimized model using those results, and then it does an eval based on that. And that's with 6 lines of code. And so if you want to see this in practice, this is kind of what we're going to do. I just walked through this, so I'll show it to you real quick. So here's a New York Times connection puzzle. You got 16 words. You got to find 4 groups. There's hidden categories and meanings to these things as well, so it's not always obvious what you have to do. And words can belong to different categories as well, so it's a little bit tricky. And you only have 6 chances to guess what goes on in here. And so with DSPy, we'll just jump in. You create these signatures, right? This is the signature I created before anything was optimized. I had basically a prediction function. I said, run chain of thought. Chain of thought is basically an LLM that runs, thinking through it. And I said, your inputs are really rules. So how does the game work? Very simple rule. The words you're allowed to use, the history, so what you've been working on so far, and what guess number you're on. Those are the only inputs that I asked it to provide. And the output, I said, give me a guess, 4 words, separated by a comma. That's it. And then to build the performance is pretty simple. You give it examples. An example is just a very simple class with an input and an output. And then you can run an eval on that example by providing it a metric. And so in my case, my metric is, was it correct within 6 tries? A very simple metric. But you can have multiple metrics here on efficiency if you cared, for example, about how quickly it did. You could have metrics that take into account difficulty. But for our case, the metric is simple enough was it successful? And what you get is instant observability, too, if you put it into Dagster, right? So we use that component library. We put it into Dagster. And you can actually track performance over time as well of these things. You can see here on the bottom right, I'm outputting metrics from my pipeline, and then you can track that on the right. Presumably, if you had multiple steps, you would see like a line graph. And here's what components looks like for our DSPy module. Again, kind of hard to read, but on the left, you could imagine you're just providing the parameters of this model. And then on the right, that's the code that builds this model in Dagster itself. And so you can create these assets within Python, and then take that input from the YAML and convert that into a pipeline, which gives you this. Again, here's the results. We did 100 puzzles, a 32% success rate on Grok 3 Mini, actually, so a very affordable, cheap, and quick model. After optimizing this way, basically we got 21% performance gains for free. The only optimization we used was MePro v2, which is like an out-of-the-box DSPy optimizer. And what that does essentially is it looks at the failures and the successes, and based on that, it asks an LLM, how would you improve this prompt to improve the performance of this model? And it adds like a few short examples as well, and just through those 2 steps, which you don't have to do any of it yourself, it improves the performance of the model pretty quickly. The full results are on my website too, so if you go to pedramnavid.com, you'll see the blog posts about this and like the full code if you wish. What's really interesting is like across the board, most models saw quite good performance improvements. Some not as good. Like if you look at GPT-5, for example, from 93 to 98, like there's not a lot left to squeeze out of that model. And then for GPT-4.1 Nano from 2 to 7, probably not worth it, but very cheap. And so there's always like this like balance you got to put in between how much time you want to spend on these things, how much money you want to spend, and how much performance you want. And there's no real like perfect answer. But in my testing, I found something like Sonnet 4 to be really good. Where's Mini? GPT-5 Mini, I mean, out of the box, unoptimized for $9 is actually quite good. And you can squeeze that to 98 in an hour. I thought that was actually a really, really good model. But there's not a lot of performance left to squeeze out of it too, which is really interesting. So you do this. You start in a world of manual prompt tweaking, notebook chaos. You didn't have any versioning. Blind deployments really had no sense of what's going on. you move to this declarative approach, and what you really get is automatic optimization. You get pipelines that are production ready out of the box. You get full model lineage so you understand how your pipelines are working, and you get this continuous eval that can constantly self-improve and self-heal over time. So those are my key takeaways. Stop writing prompts, use DSPy, never write prompts again. That's my #1 tip for all of you. Stop using scripts. Use Dagster from the start. Very easy to get started, and you'll get pipelines that work really, really quickly. And stop accepting poor performance. Your models can be better. And that's it. And I think we have time for questions.
Yeah, thank you. Super interesting. I was just wondering, so you say that the prompt is being optimized, right? So does that mean that there is a actual readable prompt that we as humans can read? And is it stored somewhere? And
yeah, that's a great question. So there is a prompt, but it's not a single prompt. The prompt can change over time. And so in DSPy, what you would do is you would compile your model. That compiled model can contain prompts in it, but you won't know the actual prompt until the thing runs. And so that's why observability is really important. A tool like MLflow, for example, would capture the prompt at runtime, and you would see, for this model, here's the exact prompt it ran, and so you can do that as well. Yeah. All right. Thank you. Oh, one more here.
Hey, thanks. It's a great talk. I'm actually a big fan of DSPy as well, but what I found is that if you actually look at prompts that we're building, like one of the prompts that I've built very recently is about 100 lines.
A little louder.
Sorry.
Yeah.
One of the prompts that I've built recently is like about 100 lines. As you said, it becomes very messy, right? Only maybe 5 or 10 lines out of that is actually description of what kind of output I want. Everything else is instruction on how to perform the task that I'm asking you to do. And that's where I've actually found that DSPy doesn't really help me. Somehow I still need to pass this instruction set into the LLM, right? It's not just about defining the input and output fields. I also need to tell it what it is, what I want it to do, how I needed to handle certain things. Like for example, I'm doing video metadata labeling, right? So I want to tell it that this is the kind of videos, and I'm asking you to do these kinds of topics.
Right.
And when you're picking that type of topic, let's say the age group, then I want you to use these kinds of rules and all of that stuff. So DSPy doesn't seem to help me with that bit.
Do you have like an eval set? Are you optimizing for a particular, and through optimization it's not getting better? Oh, let's talk after. You took your. All right, thank you.